Good evening, ma'am.
Good evening, sir. You can start now, sir.
Welcome. The first chapter in chemistry, 11th standard, PUC 1, is basic concepts of chemistry. In this chapter, we'll be learning about the basics, very basics of chemistry. That is, we will be learning about units and dimensions. We'll be learning about concentrations, expressing concentrations different ways, calculating the concentration of the solutions prepared. We'll be talking about matter, different types of matter, some of the properties of matter. We'll be discussing about what is an atom, what is an element, what is a molecule, properties of all this. So the first chapter, the aim of this chapter is Introduction to Chemistry and the unit and dimensions. Now, why chemistry? Now, chemistry is within us as well as around us. Everything is chemicals. Our body is made up of particles. Our body is made up of chemicals. We survive because of the chemical reactions taking place in our body. Our body is made up of carbon, nitrogen, oxygen, hydrogen. These are elements. And our body contains calcium, magnesium, sodium, potassium. These all are metals. Our body also contains gold, a very, very less percentage. So chemistry is within us and around us. The toothpaste, what we use to brush our teeth, is a chemical. The water we use to drink and clean ourselves is also made up of chemicals. The food we eat, it's made up of components, chemicals. So chemistry plays an important role in day-to-day life. Now, chemistry deals with the composition of matter. We will learn about the topic matter in detail in a few minutes' time. Composition of matter, or what do you mean by composition of matter? What all elements are present in matter? Its properties, structure. It also deals with relation between changes in composition and changes in energy. So chemistry deals with the relation between changes in composition and changes in energy. Now, for an example, if we take water, H2O, in the solid state, it's called as an ice. When it is kept out of the refrigerator, water absorbs energy, and water, which is in solid state, starts melting to give water in liquid state. Now, the composition remains the same, but during this process, water absorbs energy from the sun. So therefore, there will be change in energy. But now chemistry is a science. It's not an art. It is a science. Science is systematic study of knowledge. So science is defined as systematic study of knowledge. Whatever is known, when we systematically study that, then we call that as science. It is not an art. It is not a technique. It is a systematic study of knowledge, is called as science. So chemistry is an experimental science. Chemistry is an experimental science which concerns itself with the study of matter. Due to its abnormal development, chemistry has been divided into a number of branches. The important branches of chemistry are. So the chemistry we have more than 350 branches. more than 350 branches. But the main important branch of chemistry is inorganic chemistry, organic chemistry, physical chemistry, and analytical chemistry. There are 350 branches, as I was telling you, and all the 300 branches of chemistry broadly can be summed up and put into four branches. One is inorganic chemistry, organic, physical, and the fourth one is analytical chemistry. Now, inorganic chemistry, what do you mean by inorganic chemistry? Under this title, we study all the elements and their compounds. Compounds of carbon and compounds of carbon are not dealt in this branch. Excepting carbon compounds, all the other compounds what we learn, all the elements what we study will come under inorganic chemistry. Excepting for carbon compounds, all the other elements, all the other compounds, all the other molecules we study is called as inorganic chemistry. The second branch is organic chemistry. Organic chemistry is the study of carbon and its compounds. Compounds of carbon. Study of compounds of carbon is done in this branch. The carbon oxides, carbonates, etc. are studied in inorganic chemistry. So study of carbon and its compounds is called as organic chemistry, except for carbon oxides. When I say carbon oxide, carbon monoxide is an inorganic compound. Carbon dioxide is an inorganic compound. Even though it contains carbon, these are exceptional. We study as an inorganic molecule. Likewise, sodium carbonates. When we say carbonates, sodium carbonate, sodium bicarbonates, potassium carbonate, potassium bicarbonate, all these are not studied under organic chemistry. They are studied under inorganic chemistry because of some exceptions, because they have mineral origin, meaning these are produced from minerals by reaction of acid and base, where we produce all this. So we don't study this under the branch organic chemistry. The third branch in chemistry is physical chemistry. The laws and principles of chemical reactions are studied in the branch of this chemistry, physical chemistry. The laws and principles of chemical reactions. Now, laws and principles of chemical reactions, when we say the speed of the reaction, one is speed or the rate of the reaction, we can study under physical chemistry. The nature of the reaction, whether it is one-step reaction or a multi-step reaction, we can study. The mechanism of the reaction, we can study. All this can be studied under physical chemistry. And the fourth is analytical chemistry. This branch emphasizes the techniques that is used to find out the composition of matter. So analytical chemistry, the name itself says analysis. Analysis means finding out. Finding the elements present in the compound and how much is present. Now, analytical chemistry deals with the detection and estimation. Estimate means how much is present. This detection is also called as qualitative analysis, and estimation, finding how much, is called as quantitative analysis. Now, traditional methods are there in analytical chemistry, as well as we have modern instrumental methods. Now, one more branch I have to mention here, that is in 12th standard or second PUC, you have the fifth branch, that is biochemistry. You have introduction of biochemistry to like study about carbohydrates, study about proteins, nucleic acids, all that will be done in biochemistry. It is in second PUC. In 11th standard, we will be learning about inorganic, organic, and physical chemistry introduction. Now, the physical quantities and their units. Now, in order to start to learn or understand chemistry, we should know the physical quantities and their SI units, standard units. Chemists describe the behavior of chemical substance on the basis of physical and chemical properties. Chemist means a person who studies chemistry are called as chemists. So chemists describe the behavior of chemical substances on the basis of physical and chemical properties. The measurements of chemical properties involves chemical reaction. Measurement of chemical properties involves chemical reaction, whereas measurement of physical properties does not involve any chemical reaction. Now, for an example, if you take calcium carbonate, if you burn calcium carbonate or if you heat calcium carbonate, this calcium carbonate will decompose to form calcium oxide, giving you carbon dioxide. The measurement of carbon dioxide, the amount of carbon dioxide formed, is calculated based on the chemical property here. This is a chemical property. It's a decomposition of calcium carbonate. Now, if you talk about the boiling point of water, boiling point of water does not depend on the amount of water. So this property, determination of boiling point of water, determination of surface tension of water, determination of viscosity of water, all those does not involve any chemical reactions. So physical properties does not involve any chemical reactions. Now we have around 7 fundamental units, physical quantities and their units. Common physical properties are mass, length, time, volume, temperature, density. And we have one more called as luminous intensity. We do not talk about luminous intensity. So the 6 components we need to learn in detail. The first one is mass. Mass tells us about the quantity of matter. Quantity of matter. Quantity stands for amount, how much of matter is present. Mass tells us about the quantity of matter. Mass is measured with the help of analytical balance. Now, the physical balance you would see in the shops when we buy any groceries, people weigh using the physical balance. Nowadays, they have electronic balance. The accuracy in the physical balance and electronic balance is very less. But when we use analytical balance, up to 4th decimal, we can have accuracy. We can measure up to 4th decimal. Even in chemistry in the modern days, we are using electronic balance. So chemical analytical balance is forgotten, but you should know that mass tells about the quantity of matter, and it is measured using the help of analytical balance. The next, size of the object is measured in terms of length, area, and volume. Size of the object is measured in terms of length, area, and volume. Length refers to one dimension. Length refers to one dimension. Area refers to 2 dimensions, and volume refers to 3 dimensions of space. So length, if we take A, these are points A and B. This is the length. So it's one dimension. But if you take a square, the area of the square is length into breadth. If I take this as A and B, A into B will give you the area. Or if you take the volume, length into breadth into height, 3. Or maybe it's a 3-dimensional. If you write a cube like this, a cube will show length into breadth into height. That will give you the volume. So cube is a 3-dimensional representation. The third, I'll give you the units for the mass, size, and time and other units. Now, the time helps us know how long it takes for a process to occur. Time helps us to know how long it takes for the reaction to take place or a process to occur. Generally, time is measured in terms of seconds. So here, the 7 basic quantities here we are measured, namely, even the luminous intensity is mentioned. So mass, length, time, temperature, electric current, luminous intensity, and amount of substance. Amount of substance we'll have to learn in detail. It itself takes a longer time to understand the concept. All the units can be derived from them are called as derived units. So using 7 basic units, whatever other units we know are called as derived units, like area, volume, force, work, density, velocity, energy. All these are called as derived units. All these are called as derived units. Now, physical quantities and their SI units. Now, the SI units of the 7 basic units. The 7 basic units is the physical quantities. The first one is mass. Where's that mass? Here. I use a different color. We are not able to see that, So I use a different color. The first one is mass. Mass is the amount, quantity, as we learned. So the unit for mass is kilogram, and the abbreviation for kilogram is kg. The first fundamental unit of quantity, physical quantity, is mass. The unit, SI unit for mass is kilograms, and the abbreviation is kg. The next one is length. Length is always expressed in terms of meters, and m is the representation of meter. The third physical quantity is temperature. Temperature is measured in Kelvin scale. Normally, we measure temperature in degrees Celsius. And convert it into Kelvin scale. The SI unit for temperature is Kelvin, and the representative abbreviation is capital K. The fourth is most important and vast topic, which we'll be handling in classes further later, following classes. Amount of substance. Amount of substance is expressed in terms of moles. Mole is called as chemist's dozen. Mole is called as chemist's dozen, and the abbreviation for mole is MOL. Time, the duration for the process to take place, or the duration for the reaction to take place, is expressed in terms of time. And time, the SI unit or time, is expressed always in seconds, and it is represented by letter S. Electric current. The sixth physical quantity is electric current. Electric current is expressed in terms of amperes, and it is A. Luminous intensity is expressed in terms of candela, and it is CD. The abbreviation is CD. Generally, we use this luminous intensity to a very, very less extent in chemistry. Otherwise, the 6 terms, the 6 fundamental quantities are physical quantities like mass, length, temperature, and time, electric current, we will be frequently using. Now, derived units. Derived units are units which is derived from the fundamental units. Those are called as derived units. Now, units of different physical quantities. Units of different physical quantities can be derived from 7 basic units, are called as derived units, because these are derived from this fundamental basic units. We learned the fundamental basic units: mass, length, temperature, amount of substance, time, electric current, luminescent. From these, the units what is being derived, what we get, are called as derived units. For deriving these units, we can multiply or divide symbols for units as if they're algebraic quantities. Now, for an example, volume. Volume is one of the derived units. Volume we know is length into breadth into height. If the units of length are m, the unit for breadth is also m, and also for the height is m, then we can write volume is m into n. That's m cube, meter cube. So the unit for volume is meter cube, and meter cube is the example for derived unit, because we are deriving it from the fundamental unit. The fundamental unit is meter for length. Similarly, for breadth and height, it is what? Meters. So meter cube is the unit for volume. Likewise, the second we are talking about is area. Area is length into breadth. The unit for length is meter. The unit for breadth is also meter. So therefore, the unit for area is meter square. Now, we learned the unit for volume. The SI unit is meter cube. And area, the SI unit is meter square. The third is density. Density is represented by mass by volume. Mass is a fundamental unit, and the unit for mass is kg. Volume we represent as meter cube. So the unit for density is kg per meter cube, or we can represent it as kg meter cube per meter cube, like this. Either ways we can write. It is same. The fourth derived unit, what we are learning, is called as acceleration. Acceleration is velocity by time. The ratio of velocity by time is called as acceleration. The unit for velocity is meters per second. Distance traveled per second is called as velocity, meters per second. And the unit for time we learned, it's a fundamental quantity, and it's represented by time s. So we can write this as meters per second by s per second, or we can write it as meter per second square. The unit for acceleration, SI unit for acceleration, is meters per second square. Force. The next derived unit is force. Force is a product of mass into acceleration. Mass, we know the unit is kg. We learned acceleration to be meter per second square. So therefore, the unit of force is kg meters per second square. These all are derived units. Area, volume, density, acceleration, force, these all are derived units. Now, the next is pressure. Pressure is defined as force by unit area. Force by unit area is called as pressure. The unit for pressure is kg meter per second square. Kg meter per second square. And area, we learned it is meter square. Therefore, the unit for pressure is kg. This meter square will get, this meter will get cancelled. If this meter goes to the numerator, we'll write as kg per meter per second square. We can write this as kg per meter per second square. Either ways, it is same. Energy and work. It is force into distance. Force, we have learned it in the previous slide. Force is kg meter per second square. So the unit for force is kg meter per second square. And unit for distance is meter. So therefore, the unit for work is kg meter square per second square. This kg meter square per second square is commonly called as joule. This is represented as joule. These are the basic. Few more. We have electric charge. Electric charge is current into time. Current is electric charge is current, a product of current into time. Current we express in terms of amperes and time in terms of seconds. So it will be ampere seconds. That will be called as coulombs. Next, electric potential. Electric potential is a ratio of energy by charge. Energy, the unit is kg, meter square per second square. Charge, electric charge is ampere per second. That will be equal to joule per ampere per second. Joule per ampere per second. This unit is joule. Joule per ampere per second is the unit for potential, and it is commonly represented as a volt. So volt is joule per ampere per second. So these basic units as well as the derived units are supposed to know, because you need to understand the conversions. We will learn the conversions of different factors in further classes. Now, this is the summation for derived units. Velocity, take a different color. For velocity, the representation is V, meters per second, symbol is ms inverse, or we can represent this as meter per second. Either ways, it is right. Area, length into breadth, and it is SI unit is square meter, represented as meter square m to the power 2. Volume, length into breadth into height, the SI unit is cubic meter, and it's m to the power 3 meter cube. Density is represented by letter rho. This is called as rho. It's not P. Density is kg per meter cube. This is the SI unit. In CGS unit, it is gram per centimeter cube. We will learn later. The SI unit for density is kg per meter cube. Representation is kg per meter cube. Energy, it's E. The unit for energy is joules. Kg meter square per second square. Kg meter square per second square. Force, represented by the F. The SI unit is Newton. Kg meter per second square is the symbol for Newton. Kg meter per second square. Frequency is represented by letter nu. Nu. It is a Greek letter. Nu, it is not V. So the unit for frequency is hertz, cycle per second. Pressure, represented by letter P. The SI unit for pressure is Pascal. Newton per meter square. We can otherwise represent as Newton per meter square. And electric charge, the unit, SI unit is coulombs, ampere second. Ampere second. These are some of the derived units which we know in order to the chemistry. Next, we have prefixes. The SI unit of some physical quantities are either too small or too large. Physical quantities are either too small or too large. To change the order of magnitude, these are expressed using prefixes before the names of the basic units. Since the physical quantities are very small, too small or too large, and to change the order of the magnitude, they're expressed using prefixes. Now, so many are there. We are not going to learn about all these. But anyways, now 10 to the power 1 is called as deca. Then we're going from down 10 to the power 1 is deca. 10 to the power 2 is called as hecto. 10 to the power 3, that is 1000, is called as kilo. 10 to the power 6, when we say 10 to the power 6, yeah, 10 to the power 3, it means 1000. 10 to the power 6, 6 zeros. So it's called as mega. 10 to the power 9 is called as giga. 10 to the power 12 is called as tera. 10 to the power 15 is called as peta. 10 to the power 18 is called as exa. 10 to the power 21 is called as zeta, and 10 to the power 24 is called as iota. The symbols you can see for deca, it is Da, hecto, it is H, kilo, it is K, Mega it is capital M, giga is G, tera is 12. At least maybe till 10 to the power 15 we'll learn peta is capital P. Here you can see the powers are all in positive. 10 to the power 1, 2, 3. Now, if you take 10 to the power minus 1, 10 to the power minus 1 means 1 divided by 10 is called as 10 to the power minus 1. If this 10 goes to the numerator, you'll get minus 1 power. It's called as deci. 10 to the power minus 1 is called as deci, represented as capital D. 10 to the power minus 2 is called as centi, capital C. 10 to the power minus 2 is 1 by 100. 10 to the power minus 3 is 1 by 1000, called as milli. 10 to the power minus 6 is called as micro, and representation is mu. 10 to the power minus 9 is nano, represented by capital letter N. 10 to the power minus 12 is picometers. We study the atomic radius of elements in terms of picometers. Picometer is 10 to the power minus 12, represented by capital letter P. 10 to the power minus 15 is femto, and represented by small letter F. 10 to the power minus 18 atto A, 10 to the power minus 21 zito Z, 10 to the power minus 24 yocto Y. Conversion of units. This is important for us to know, conversion of units. From minutes to seconds, seconds to minutes, centimeters to meter, meters to centimeters, millimeters, etc. Conversion of units. Now it is used to convert one set of units to another in calculation. So conversion of units, it is used to convert one set of units to another in calculation. In order to use this method, we write the units with every number and carry the units through the calculation, treating them as an algebraic quantity. So conversion of units is to convert one set of unit into another for calculation purposes. That's called as conversion of the unit. Now, for an example, the SI unit for time is seconds. The SI unit for time is seconds. But in the problems, in the numericals, if they give time in minutes, we need to convert the time in seconds. Or if they give time in hours, we need to convert in seconds. Or if they give time in days, we need to convert in seconds. We should know. That process is called as conversion of units. The conversion of units of time, we know that 1 is equal to 60 seconds by 1 minute. That is, see, if you multiply this, 1 is equal to 60 seconds per minute. So 1 and 2, 1 minute is equal to 60 seconds. What we understand by this, 1 minute is equal to 60 seconds. Or if you take 1 is equal to 1 minute by 60 seconds here, we can write 60 seconds. 1 into 60 will be 60 seconds. 60 seconds will be equal to 1 minute. Both are same. 1 minute is 60 seconds, or 60 seconds is called as a minute. These quantities are called unit conversion factor, or conversion factor, or simply unit factor. This is very simple. Now we'll learn some of the examples. To find the number of seconds in 5 minutes. To find the number of seconds in 5 minutes. So we know that 1 minute is equal to 1 into 60 seconds by 1 minute. We learned it like this. 1 minute is equal to 60 seconds by 1 minute. So since they're asking us to convert 5 minutes, so 5 minutes will be equal to 5 minutes into 60 seconds by 1 minute. So what happens? This minute will get cancelled. So 50 into 60 is 300 seconds. So that means 5 minutes is equal to 300 seconds. 5 minutes is equal to 300 seconds. Now, this is these kind of conversions are a little complex. We should pay attention. Now, the next one is convert 0.74 angstrom this one, convert 0.74 angstrom, a the power like 0. This is called as angstrom unit. Convert 0.74 angstrom unit into a picometer. For this, we should know that 1 angstrom unit is 10 to the power minus 10 meter. So 1 angstrom unit is 10 to the power minus 10 meter. If that is the case, 0.7 angstrom, 74 angstrom unit is equal to what in meters? So it is only a cross multiplication. So 0.74 angstrom into 10 to the power minus 10 meters divided by 1 angstrom. That is equal to, this will get cancelled. So we'll have 0.74 into 10 to the power minus 10 meters. So we are understanding that 0.74 angstrom is 10 to the power minus 10 meters. 10 to the power minus 10 meters. So 1 picometers. Now they're asking the question is 0.74 angstrom into a picometer. Now we know that we have to convert this 0.74 meters into picometer. So since there's no place, I will write here. 1 picometer is 10 to the power minus 12 meters. 1 picometer, this is 1 picometer is 10 to the power minus 12 meters. So 0.74 into 10 to the power minus 10 meters will be equal to how many picometers? So it will be 1 into 1 picometer into cross multiply 0.74 into 10 to the power minus 10 meter divided by 10 to the power minus 12 meters. So meter and meter will get cancelled. So if this 10 to the power minus 12 goes numerator, it becomes plus. Plus 12 minus 12 becomes 2. So therefore, it will be equal to 0.74 into 10 to the power 2 picometers. So this is the conversion. So 0.74, finally we can write here, 0.74 angstrom unit is equal to 0.74 into 10 to the power 2 picometers. Conversion is for 74 picometers. We can write this as 74 picometers as they've written here. 0.74 and 10 to the power 2 picometers can be written as 74. Now, conversion of liter atmosphere to joules. Conversion of liter atmosphere to joules. Now, we know that 1 liter is 10 to the power minus 3 meter cube. Or we can write 1 is equal to 10 to the power minus 3 meter cube by 1 liter. So 1 liter atmosphere is equal to 1 liter atmosphere into 10 to the power minus 3 meter cube by 1 liter. So 1 liter atmosphere is equal to, now this liter and this liter will get cancelled. So 1 into 10 to the power minus 3 is 10 to the power minus 3. 10 to the power minus 3 meter cube atmosphere. So that is what they give, 10 to the power minus 3 meter cube atmosphere. This is very important. This is very important. So pressure are expressed in different terms. 1 atmospheric pressure is 101,325 pascals. Or we can write this 1 atmosphere is equal to 101.325 kilopascals. This relation is important. 1 atmosphere is 101.325 kilopascals. Or in terms of meter atmosphere, here in terms of atmospheres, 10 to the power minus 3 meter cube atmosphere is equal to 10 to the power minus 3 meter cube atmosphere into 101.325 pascal by 1 atmosphere. So this atmosphere and this atmosphere gets cancelled. So we have 101.325 pascal, 10 to the power minus 3. This is 10 to the power minus 3 meter cube. So we will have 101.325 pascal meter cube. This is not required. All right, 101.325 is also called as Newton meter. 101.325 is also called as joules, because 1 Newton meter is nothing but joules. Precision and accuracy. The next concept we have learned so far, the fundamental units as well as derived units, and also we have learned a few interconversions of units. We will learn about the other conversions as we work out some of the problems in the later stages. Now, precision and accuracy. What is precision and accuracy? Of different scientific measurements, two terms, accuracy and precision, are commonly used. Accuracy is a measure of the difference between the experimental value and the true value. Now, accuracy is the measure of the difference between the experimental value and the true value. Now, for an example, if the true value of an experiment, is 10.0 centimeter cube. Assume the volume of the expected experiment is 10. That's a true value. When you perform the experiment and if you measure the volume, if we are getting 9.9 centimeter cube, three times you're repeating and you're getting the answer to be 9.9. The difference between the experimental value and the true value is called as accuracy. In other terms, in simple ways, accuracy is defined as the value which is closest to the true value is called as accuracy. Now, 10.0 and 9.9, they're very close. So when you repeat the experiment more number of times, still if you're getting 9.9, 9.9, then we say the accurate value is 9.9. The small difference between the experimental value and the true value, larger is the accuracy. So the difference is very small. Now, for an example, if another person is performing the same experiment and if he's getting the value 9.5 centimeter cube, expected is 10, true value is 10, the experimental value is 9.5. The difference is 0.5 centimeter. That means the difference is more. The difference is more, accuracy is less. Accuracy is less. So closeness to the true value is called as accuracy. So accuracy expresses the correctness of measurement. Accuracy expresses the correctness of measurement. Now, the second term is called as precision. Precision is the difference between measured value and the arithmetic mean value for a series of measurements. Now, the same experiment, the true value is 10.0 centimeter cube. The experimental value is 9.9. Second time you represent 9.8. The third time you perform 9.7. So the difference between the measured value and the arithmetic mean. So if you take the mean of this, it will be 9.9 plus 9.8 plus 9.7 divided by 3. If it is x, the difference between x and the measured value, experimental value, is called as precision. Precision is the repetition or the repetition of the same values obtained is called as precision. Closeness to the value obtained is called as precision. It is not close to the true value. Closeness to the value. So 9.9, 9.8, 9.7 are close to each other. Therefore, we say these are precise. That's called as precision. Precision refers to closeness of set of values obtained from identical measurement. That is what I told you. So 3 times the experiment is performed and the values are close to each other. That's called as precision. Example, we will take 3 students were asked to determine the mass of piece of metal, where mass is known to be 0.52 grams. Data obtained from each of the students recorded. Student A refers 0.521, 0.515. The average is 0.509. And the second student 0.516 and 0.515. The average is 0.514. Student C, the third student, 0.21, 0.20, and the average is 0.20. Now, this is close to this value, 0.20, not this, the average. And this is close, 0.15 is close to this. So, precision refers to the closeness of set of values obtained from the identical measurements. Data of a student A are neither very precise nor accurate. Data of the student A are not precise nor accurate because the expected answer is 0.20. It is so the answer student A does not get 0.20, nor the second time when he repeated got the same value. Therefore, it is neither precise nor accurate. Second student B was able to determine the mass more precisely. See, it is not close to the true value, but his values, these experimental values are close to each other. Therefore, this is precise and not accurate. Now, the third student, if you see, this is accurate. 0.520, this is accurate. And 0.521 is also close to this. This is precise. So student 3, the values obtained by the third student is precise and accurate. So this is about precision and accuracy. Whoa, this is an important topic, scientific notation. We will have a lot of questions in the sense, one question in CET, one question they can ask you in NEET or competitive, at least in CET, they ask you one question, or they may ask you in 11th standard, regular questions, can ask you a question. So the scientific notation, possibly, since we have to handle it in detail, we will learn in the next class because it is a big concept which we cannot finish in a few more minutes time left. So we will stop the class till here, precision and accuracy. Ma'am?